All right, on to the next portion of area and arc length. This time we're going to be talking about arc length. So let's define what an arc is in a circle. An arc is a portion of a circle that's around it. So when you think about a distance between 2 points, of course we want to normally pick the straight line, but on a circle, it's the portion toward, from one point of the circle to the other that actually goes on the curved part of the circle. So an arc is like the portion of a circle, not inside of a circle, portion of a circle. Maybe on a circle would be better. You're going to see a couple other words: subtended angle and intercepted arc. A subtended angle is an angle that goes through usually the center of a circle. It doesn't have to be, but it's an angle that goes through the center of a circle such that the angle intercepts an arc on the circle. So it's an angle that intercepts a circle's arc. And then finally, the intercepted arc is just the arc that we're talking about. So like if I say angle ABC is subtended angle ABC intercepts arc AB, for example. The arc that angle intercepts. Intercept means, of course, just to cross, like y-intercept. So we're going to be talking about a formula. It's much related to the circumference. Remember, circumference is the distance around. So circumference would be 2 pi r. So the length, which we call length, is basically equal to the circumference. Okay, that whatever measure the circumference is, times the degree of the central angle. So we'll say times degree over 360. So the degree in this case being 80 and the radius being 10. And if you want to just go right to the formula, you could say L equals 2 pi r, because that does represent circumference, times degree over 360. That's what I usually use. So a couple things in common with the last one. We have the degree, we have the 360, we have the radius, but it's not pi r squared, it's 2 pi r, and that's what makes it different. So let's talk about example 1. If the length of an arc, if the circumference of a circle is 40 pi, what is the length of an arc intercepted by a 25-degree subtended angle? So the degree is going to be 25. And we're going to plug it into L equals 2 pi r times degree over 360. Now in this problem, they give you the degree, they give you the circumference, not the radius. So in my opinion, it would be easier just to plug the 40 pi right in for circumference and bypass the 2 pi r portion. So I would just say circumference times degree over 360. And then we can plug in circumference, which is 40 pi. So 40 pi is representing your circumference. You could break it down and solve for the radius if you wanted to and plug it into 2 pi r, but you're going to get the circumference anyway. So that's going to go into the circumference portion. The degree portion is going to be, what did we say it was, 25 degrees. And then we're going to divide that by 360. And I want to include that in terms of pi first. So what I'll do on the calculator is I'll say 40 times 25 over 360. So if you rearrange it, kind of put the pi last, I guess, you could say 40 times 125, or times 25 over 360, and then just say times pi. And just put that portion in your calculator if you want it in terms of pi. So that's what I'm going to do. times 25 divided by 360. And that's about 2.77 repeating. I'm going to hit the fraction button and make it a fraction. So we're going to say 25 over 9 pi. Now, length is like circumference, so it's not going to be in square meter units, it's going to be in units. So we're going to say in centimeters. And that would be your answer as an exact answer in terms of pi. If you want that as a decimal, (25 over 9), and then multiplied by pi. So that's going to give you about 8.7266. So we'll say is approximately 8.73 centimeters. So either one of those answers are acceptable if it doesn't specify 25 over 9 pi times pi, or just 25 over 9, or just 8.73 if you round it. Now, yeah, so that's all that needs there. So either one of those is acceptable. Let's look at the next one. Okay, question 2. A central angle of 72 degrees, there's your degree, intercepts an arc length of 12.6 meters. So that's not a radius or diameter, it says arc length. So they give you what it equals, and they want to know what is the diameter of the circle. Round to the nearest hundredth of a meter. So let's write our formula out and figure out what we have. Our formula is L equals 2 pi r times degree over 360. Now I have the degree and I have the L. So we're going to substitute those numbers in for both of those. 12.6 for L, degree being 72. So 12.6 equals 2 pi r times 72 divided by 360. There's a bunch of different ways to do this problem. We can get rid of each one of these items individually. My typical way of doing this is just to get this to one number times r. So what I would do in the calculator, if it were me, is just to say 12.6, put the r at the end. It's 2 pi times 72 over 360 times r, right? So if I have that r there, just leave it alone. I can put 2 times pi times 72 divided by 360 and figure out that one. That's what I'm going to do. 2 pi parentheses 72 close parentheses divided by 360. Now notice that I put the whole thing over 360. That's okay. You can, if you want to separate it out, you could do times 72 divided by 360, and it should give you a separate fraction, but it's going to give you the same number. So I'm going to say that's approximately 1.2566. I'm going to go out a few decimal points. So I'll say 12.6 equals 1.2566. It's okay to be precise. You know, when you're working through a problem, rounding shouldn't happen really too much until the very end when you want to finalize your answer. So that's multiplication. We get rid of multiplication by dividing. So I can divide both sides to get r by itself by 1.2566. And those will cross out. And that's approximately equal to 10.027. So what do I want to round that to? 10.02, so 10.03. Just leave 10.027 as your radius. That's great. That's my radius. But it doesn't ask for the radius, does it? It asks for the diameter. So in a circle, the radius is halfway through the diameter. So the diameter is going to be twice that. So if I multiply that number by 2, you get about 20.054. So my diameter is, I'll say 20.05. And let's look at our units. Our units are going to be in meters. Diameter is a length, so we'll say meters. And that's your problem. So here is the work for that, if you want to go back and take a look. All right, example 3. In the circle shown, what is the length of arc ABC if its radius is 8 inches? This one's a little tricky, isn't it? So let's look at what it's asking for. It wants to know the length of arc ABC. Now, if I'm trying to find that arc, which arc are we talking about? This arc right here would be arc CB. That's not ABC. This arc here would be AC. If I did this whole arc, that would be ACB, but that's not in the right order. So if I want to know ABC, I have to start at point A. I have to hit B next without anything in between. So I need to go this direction. That's counterclockwise. And then I have to continue it until it finishes up at C. So that is actually the arc I need to find the length of. It's not just this portion here. It's CB and AB together. So let's break down what both of those are. I know CB is going to be 40 degrees. Okay, that's right there, that's given. I can assume that this is a diameter. So that means that this is going to be half the circle. An entire circle is 360 degrees. Half a circle or semicircle is 360 divided by 2, which is 180. So that's 40, that's 180. And together, that combined degree will be what we need to use. So the degree of arc ABC is going to be 180 plus 40. And that's going to be 220 degrees. That's the degree we're going to use. It also gives you a radius of 8 inches. So R is going to be 8. And the degree is going to be 220. So we'll use our formula, 2 pi r. Times degree over 360. And you go ahead and plug those in. Get your answer in 2 forms, in terms of pi and as a decimal. Pause the video and I'll wait, or you can wait after you finish it up, or then you can click on pause and check my answer. All right, hopefully you've gotten a chance to work it out. Let's plug in our radius, so 2 pi times 8. Let's plug in our degree, which is 220. Now, as a number times pi, we want to include everything but pi. So I'm going to put these 4 numbers in the calculator and, let's see if we can get a fraction or whatever that's going to be. So that's about 9.777 repeating. We'll click the fraction bar, and we'll call that about 88 over 9 pi. And our units are in inches. Now, 88 over 9 pi doesn't really mean a whole lot. So let's figure out what that is as a, you could go back right to the formula if you want. You don't need to separate them out. That's about 30.71, or you could go back to your 88 over 9 and just type pi afterwards, and that'll get you the same thing. So we'll say about 30.7177, or approximately 30.72 inches. All right. Let's look at our last example. This one's a mixed one. All right, here's the question. The length of an arc with a subtended central angle of 80 degrees is 4 pi. Find the area of the sector formed by this angle. So let's look at what we got. We got 80 degrees, that's degree. We got 4 pi. What is 4 pi? The length, that's L. So degree is equal to 80, and L is 4 pi, and it wants to know, find the area. So if I want to find the area, let's think about what the area formula is. Remember, area of a circle is pi r squared. So I need pi r squared times degree over 360. Well, I have the degree. The degree is 80. I need the r. And in order to get the r, I have to go back to the length formula and solve for it. So let's look at the L formula now. That's 2 pi r times degree over 360. We have L, which is 4 pi. We have degree, which is 80. So plug in the 80 here. And I'm going to want to solve that for r. One thing you want to do on this problem before you do any calculator work is notice that this one does have a pi on both sides of the equation. So we'll want to divide that out so we don't have to deal with the decimal. Looks like that one's not working too well, so let's use a different color. So those pi's will cancel out. And while we're at it, we could divide both sides by 2. But I'm going to let that be for now. That's just going to be 4 equals 2 times r times 80 over 360. Let's do this at least. Let's do 2 times 80 over 360. And let's leave the r alone. So we can do 2 times 80 divided by 360 and just get that one number. I don't like that number. So 2 times 8 over 360 as a fraction is 4 over 9. That's a much easier number to work with. So we're going to call that 4 over 9. So let me move this over here for a sec. We have 4 equals 4 over 9 times the radius. Okay, so a little bit easier to work with. So now at this point, you can solve for r by just multiplying both sides by the reciprocal of that. So I can say 4. If I multiply both sides by 9 over 4, that 9 will cancel out this 9. And then 9 times 4 divided by 4. Well, those 4s will cancel out. So guess what? Your radius is simply going to be 9. 9 even. Now that we have our radius, we can plug that into our pi r squared. And our degree never changed. That's 80 degrees. So that's going to be pi times 9 squared times 80 over 360. And since my original problem had the length in terms of pi, I'm going to leave my area in terms of pi. So I'm going to go to my calculator and I'm going to put 9 squared times 80 divided by 360. Let's move that over here. Let's figure out what that is. 9 squared times 80 divided by 360. Lovely. 18 pi. So pi times 18. So we could say 18 pi, and this is, well, it doesn't give you a unit, so that area would be 18 pi square units. So there is that problem. All right, thank you for watching. Hopefully that helps you with your assignment, and if you have any questions, please reach out. You have a great day.